theory of constraints, managing bottlenecks. It is a concept that has helped us to increase our capacity by around 40% overnight without adding any resources or humans. Welcome to today's podcast, where I'll be talking about how we've introduced the theory of constraints at Steelo, the ins and outs, how we got there, what worked, what didn't work, just so that you can learn from our experience. So everything started many years ago when we were looking at improving our production rates. It's sometimes referred to as throughput, but basically efficiency. So in other words, to send more steel out to site. And the natural starting point was looking down the lean manufacturing route. So the Toyota way of manufacturing, and there are other names for it, but the typical lean manufacturing. Now with lean, as the name suggests, you need to lean everything out. So try and cut all the surplus resources, only focus on where the value is added. Now, I'm not saying that it's not true. It is true, because if you have someone doing work but doesn't add value, so like for us, it would be someone driving on a forklift with steel loaded, running around in circles, we can't charge our customers because our driver was moving or handling the steel around our production facility. So indeed, we always have to remember about where or which process adds value and which one is basically a waste. And whenever you have anything waiting to be processed, that is an obvious place to start in terms of getting rid of wasted time. So we went down the lean manufacturing route. We did the classic 5S, clearing up whole spaces, red tag areas, and sort of we called it 5S Saturdays. So we used to do every 4 weeks, where the guys used to come in and we went through the whole sort of process. But that was just scratching the surface, because as if you are familiar with lean manufacturing, there's much more to it. And one of the key parts of lean manufacturing is something called takt time. So in other words, every 5 seconds, every 10 seconds, every minute, or every hour, or every day, depending what your production is, that is the takt time where things move from one process to the next one. Essentially, this means how often the final product leaves your factory doors. So, for instance, cars could have a takt time of 15 minutes, which means that every single part is at a station for 15 minutes and then moves on to the next one, which means that at the end of the process, you have a new car every 15 minutes. So by following that methodology, I actually was contemplating, and I had already plans of how we could introduce a takt time. And as far as I remember, I was working on a takt time of 45 minutes. So I assumed that this is the average of how long it takes to fabricate a steel, and then basically subordinate all the other processes around the takt time of 45 minutes. But the closer I got to implementing it, the more I had second thoughts. I was just thinking, well, it's just so silly, because if a beam takes only 5 minutes to make, let's say it only needs one drill, or for argument's sake, there's no work at all, just painting. In the takt time world, this would mean that the person on that beam, on that station, would be done in 5 minutes, and they would basically be doing nothing for the next 40 minutes. So yeah, that was silly. On the other hand, we do get complicated beams, especially cranked beams, where fabrication can take even 2 hours. So that would mean that, first of all, we're late, because one of the fundamental rules of takt time is that you can't be late. And if you're late on that takt, then suddenly the whole manager's attention is focused on that station as to why it didn't leave within the takt time. So we would have to have some kind of built-in buffers where someone is allowed to fabricate longer than the takt time and so on, which effectively means that the takt time would be useless. So I was very close to implementing it, but held fire. for the reasons I mentioned, but I wasn't satisfied because we haven't achieved anything. So I was very close, yet we did not proceed. So it set me on the journey searching for a solution that will help in our world. Now, takt time and lean manufacturing works wonderfully when you have mass production. So if we're doing, let's say we've got an order for 100,000 cars, then lean manufacturing is definitely the way forward. You can break it down to takt time. You can break it down to stations on which it takes only 15 minutes. You can literally get rid and skim all the fat out and only focus on the necessary processes, tasks that add value. But in a world where you are doing bespoke manufacturing, and steel manufacturing is bespoke, because every single beam is different. Even from the same project, they might look very similar, but they might have holes in a different place, or they are mirrored, so you have the plates welded on the opposite side, so they're not exactly the same. They might look the same, but they're not. And suddenly, lean doesn't work in that environment. And I'm not actually sure how I came about to read or to find out about the book called The Goal. And I honestly don't remember how it all happened. I think it was just pure luck. I think it was one of the recommended books on Amazon. I got that book, and when I started reading it, I just couldn't stop. I literally had goosebumps on my skin because whatever was said there, I experienced firsthand, and those are all my pain points. Everything that was mentioned there described exactly our reality and our challenges. So it was a very quick read, very easy read, because it is a business novel. So basically there's a story about a guy, I think it was Bob Bingham, or maybe it wasn't Bob, but it was he was basically a plant manager, and intertwined in that story was his family, well, his issues with his family and his boss, and then his employees and so on. But yeah, amongst that story, there were really like golden nuggets as to how a manufacturing business should operate. The book actually starts with, let's call him Bob, meeting his professor from university at an airport. So they're sitting at a gate waiting for an airplane, and Bob says, well, we've invested in new robots. We are making a step forward. We are modernizing our plant. We have now robots. And the professor fires back, well, how many people did you lay off? Bob obviously says, well, no one. We just added robots. Okay, so how many more of the products that you make will you be able to ship every single day? Bob says, well, there isn't a plan to increase productivity. And the professor then says, well, I hate to say it, but you've just wasted money on the robots. So that is the starting line, and it really opens your eyes as to what actually is an investment and what isn't. And the whole book, actually, The Goal, is about what is the goal of a business. And they do, like Bob, the main guy, he does a lot of thinking as to what is the purpose of a business. He concludes that the only purpose of a business is to make money. Now, as much as I'm a fan of the theory of constraints and the book The Goal, I don't necessarily agree with that statement, but to some degree it is true. Their reasoning is that without money you wouldn't be able to provide a living for the employees, and you won't be able to send them like nice holidays, or you won't be able to support local charities and so on. So yeah, that is true, but from my perspective, my opinion is that if you only focus on making money, then you'd probably create a horrible place to work. So it's definitely a balance, but on the other hand, money to a business is like oxygen to humans. Without money, a business cannot operate. Therefore, it is crucial that a business is profitable. So I read the book. I was very, very enthusiastic. There are a lot of concepts there, like one of our fundamental concepts called the relay runner rule, which means that once you're assigned a task, you must run with it until you're finished, which really works well. And I'm a big fan of implementing new ideas, although I always want to test them out first. So like with the theory of constraints, my first way of testing it out, the concepts from the book, happened when I finished the book and I was in the kitchen preparing a meal. And before reading the book, the way I used to cook food was basically create chaos. I would, whatever pan or pot I needed, I would take it out and then leave it for later to wash. And then we know what happens. You've got a pile of washing up to do, but now you've got hot food waiting. So you sit down, you eat the food, then your stomach is full, so you don't really fancy standing up and doing the washing up. So you switch over to the couch and watch TV, leaving the washing up for later. And then later it's too late because you're already tired and you think you'll do it in the morning. In the morning you wake up and it's like, oh my God, there's this washing up to do. So that was quite familiar. And the thing I changed was to stick to the rule where I am not allowed to let go of a pot or pan or whatever dish unless I wash it and complete the task right to the very end. And I was amazed at the difference it made. It was almost instantly, you could see the difference. When the meal was ready, the kitchen was clean. And it was like a wow moment for myself, even though it was a small example, just the kitchen. But I was really, really excited to then roll it out into Steelo. So it took me some time to prepare for it. I don't remember whether it was weeks, definitely not months. There must have been days or weeks. Because the theory of constraints talks about predominantly something called the drum buffer rope methodology. Now, the drum buffer rope means that you need 3 elements to harness the manufacturing process. The drum is referred to as the bottleneck or the constraint, hence the name, the theory of constraint. So the thing is that you need to find within your process the bottleneck. The bottleneck is normally a process that everyone within the business knows is the bottleneck because it is the most crucial task process or the place where the whole company depends on it. So it might be the biggest machine in production, and if that machine breaks down, everyone is screwed. Quite often, in places that don't or haven't applied the theory of constraints, the bottleneck is normally where you have plenty of work in process piling up just ahead of it. So initially for us, the drum was allocated at the welding base because I initially thought that, well, if a welder doesn't weld, then it's time wasted. Because the definition of a bottleneck is that a time lost on a bottleneck process is time lost forever. You can't make it up because it is working already 24/7. And basically, if you lose capacity there, you won't be able to make it up. So initially, I thought it is the welding process because it is the key process in what we do. But then I quickly realized that actually, it's not really a constraint because we can always easily get more welders on the job, or we could basically ask the welders to stay longer. So suddenly we have some flexibility and it actually isn't a bottleneck. It took me some time to figure out, and actually I figured it out in the United States when I went for more theory of constraint training, that it is okay, and in our case is definitely the way forward, is to locate the constraint in the last process, which is deliveries. Now, the reason why I say it was okay is because based on the book The Goal, the recommendation is it should be somewhere in the middle of the process and definitely not at the end. And that is why I initially didn't put it at the end. But then thanks to sort of further education, I've learned that actually is okay. And it made sense because we can only deliver between 8 and 5. If we're late, we can't deliver later because surely one of our customers' neighbors would complain to the council. And also early, we can't deliver earlier, same reasons there are restricted hours. Immediately, we know that if we don't make a delivery today, well, that means we have to deliver tomorrow, which means that we're taking away a tomorrow slot for delivering the project that was meant to be going today. So suddenly we realized that by placing the constraints in the logistics department, deliveries, we're ticking all the boxes for a constraint. So this became our drum. And then we built our own IT system around it. So suddenly we were able to allocate each truck, each vehicle as a separate column with the hours in a day. And by doing so, we connect the end of the process, the delivery, with the very beginning when estimators talk to our customers. So the way it works, just being brief, when we talk to our customers, we look at the delivery date and we can already put that project into the right slot, onto the right truck. So that's the drum. The next one is a buffer. Now, the buffer should be located just ahead of the constraint to save the constraint from starving. So in our case, although it probably isn't the best example, but in our case means that the steel must be fabricated the day before, so that the next day or the day of the delivery, the drivers don't have to wait for the steels to be fabricated. Now, if someone places the constraint in the middle of the process, then that's quite straightforward, because you then basically create a buffer just ahead of it. And actually, we've realized that for our purposes, we had to break down our production, separate out production from the company and treat that as a smaller system. And within that system, we also have the constraint. And in this case, it is indeed our welding bays. So ahead of our welding bays, we have a buffer. Each welding bay has its own buffer, and there the rule is that there should be like steels waiting, anything between 2 to 5 steels. Now, less than 2, there's a risk that the welders won't have work to do, because the person supplying the steels just won't be quick enough to ensure continuity of work. On the other hand, if we exceed 5, that normally means that we would have to start laying steels on top of each other. So the 5 is, or the size of the buffer is designed so that we can fit roughly 5 steels on as a maximum. Now, the reason why we don't want to overfill the buffer is because if you start adding beams on top of each other, that means that the welder, if they need to reach for the bottom beam, they now waste their time, because they have to take the beams from the top to get to the ones that they need now. So this example is a classic example of something called clogging the system. So if you put too much items into the production process, then you clog the system and efficiencies drop dramatically, because now everyone is busy but not necessarily adding value. So a welder might be very busy handling steel, but like I mentioned at the very beginning, that doesn't mean we can charge our customers for handling that steel. The third part of the drum buffer rope is the rope, which basically ties the end of the process to the beginning. So like I mentioned, our estimators look at the drum to then feed the whole process with enough work so that we don't clog the system or starve the works. So effectively, we already have the rope built in because of our IT system. So an estimator won't chuck in, let's say, 15 deliveries on a single truck, because that is basically impossible. So this is the rope. And again, if we break it down onto smaller production phases, like just focusing on production, we also have a rope within our production, which means that we can't overload the buffers with material because of what I described about overclogging the production. Now, you've probably noticed I talk a lot about production, manufacturing, productivity, and so on, which is very true for us because we are a classic, traditional fabrication company, fabricate structural steel. But when you look at any business, you realize that actually every business is a manufacturing business. Even if you are a solicitor, you are actually attending a production line where the starting point is receiving some paperwork, then some work needs to be done on the case or whatever it is, and there's a defined outcome. Yes, you're not using grinders and welding machines, but you are adding value throughout the whole process. And there are plenty of other examples. Like I said, probably every single business could be broken down to a manufacturing business. And indeed, all the same principles apply. So one of the critical rules of a company that operates under the theory of constraints is that you should not flood your employees or basically whole company with work in progress. So even if going back to the solicitor, a solicitor is much more efficient if they only are working on, let's say, 5-6 cases at any given time rather than being flooded with 50 cases, because then you have all the other things creeping in, like procrastination and workaholism, where they in their minds, they just, poor guys are just flooded with work. They know they've got so much work to do. They can't get their heads around a single case because they've got all the other cases rushing in their mind. So it's a terrible, terrible place to be in. Whereas if you limit the amount of jobs, projects, or tasks you're working on at any given time, suddenly everything becomes manageable. And I guess the prime example that I really like, it's to do with something called a virtual constraint. So when we have physical constraints, like I described our trucks for the whole company, or the buffer ahead of our welding bays, they are physical constraints. You can't load more steel on a truck than you can physically fit. But in some cases, there's no real constraint. Let's say you've got plenty of space in the yard and you could technically accept as much material as possible. So the prime example I really like comes from my training in the United States, where the US Army, the helicopter maintenance facility for the US Army, they were struggling with terribly long lead times. So when a helicopter was dropped off for maintenance, it took on average 6 months for that helicopter to be back in service. And at any given time, they were working on 30 plus helicopters. So Goldratt, the author of the Theory of Constraints, he was asked to help out. He went there, had a look, and immediately knew what the issue was. Basically, they were working on all 30 plus helicopters at any given time. So his solution was to introduce something called the virtual constraint, which meant that they were artificially limited to working on 6 helicopters only at any given time. Now, it might feel counterintuitive or counterproductive, because if you're working on 6 and you don't have the parts for the 6, it's more than tempting to start working on the 7th and then 8th and then 9th and so on. But the thing that you don't realize that happens is that your focus suddenly becomes spread. So if you're only able to work on 6 and you need, let's say, a replacement artificial horizon for one of the helicopters, you will do everything it takes to source that artificial horizon. So you'll be on the case from the very first thing in the morning. You'll be calling one supplier, then calling the other supplier, and the third one maybe, and expediting the deliveries and so on. And by doing so, you're actually teaching your supply chain that you are serious about things. When you need things, you need them. You're not one of those where places an order and you can wait 5 months, as would be the case if you're working on 30 plus helicopters at any given time, because then you're teaching your suppliers that you are a slow orderer. So you place an order, but you're not really fussed as to when they deliver, which means that they will be always tempted to move you right to the bottom of the priority list. So as you can see, there are many benefits of it. So the next thing is that you can see progress. If you only have 6 helicopters on your mind, you know exactly what's going on with each one. And there's this probably dopamine rush each time you finish one helicopter, because you can see the results of your work. So in some cases, like probably a solicitor, it might be worth considering a virtual constraint. So going back to the name, the theory of constraints, the name is quite, I would say, weird. Not many people understand what the theory of constraints is about, and I don't blame them at all, because unfortunately, I myself, I wouldn't be able to explain to you what the theory of constraints is in one sentence. Goldratt himself had big problems, or he found it very challenging to explain it, and that is why he decided to write the book The Goal. But Goldratt, he used to be a big fan of simplifying things, and he just concluded that he can't be a hypocrite by telling people to simplify processes, and he himself not being able to explain the TOC, the theory of constraints, in one sentence. So he spent a few nights, maybe even more than a few nights, thinking about what is the theory of constraints, and he concluded that it's not only one sentence that describes the theory of constraints, but it's actually one word. And that word is focus. Now, focus has many meanings, but the one that he was after was the one that says, do what should be done and do not do what should not be done. And the not be done is more important than do what should be done. Now, when you first hear this, you think, yeah, it's trivial. Yeah, one of those sayings. Yeah, it's overcomplicated and so on. But when you think about it and you then compare that to real life examples, it is such a strong message. Do what should be done and do not do what should not be done. An example of this same concept is actually used in the lean startup world and in the Silicon Valley startup environment, where basically if you are not providing value and you're only burning cash, then you would have been better off lying on a beach for 2 years and just drinking alcoholic drinks, and you'd be much better off. You wouldn't have spent all the money. So that's why in the lean startup world, it's important to pivot very often and validate small steps and basically create what your customers want. So the same is in the theory of constraints. Focus on only the things that add value and disregard or simplify the tasks or operations that don't add value. So this is me about the theory of constraints. I could continue for the next probably 24 hours. I love this concept. It's such a shame that Eliyahu Goldratt is not around with us anymore. But luckily, he liked to share his knowledge, so he wrote probably 10 or more books. I read every single one of them together with all the books written by his direct students. And yeah, I couldn't recommend more. So hopefully, if you are interested in this, I might follow up with some more in-depth knowledge about the theory of constraints. That's it for now. Thank you very much. Please remember to sign up so you don't miss out on future podcasts. Thank you.